Okay, hello and assalamualaikum everyone. So kita akan continue dengan 8.5 which is diffraction by a single slit. So in 8.1 and 8.2 we have learned about interference and coherent sources, and in 8.3 we have learned about young double slit. So 8.3 kita belajar double slit, 8.4 kita belajar thin film, and 8.5 we will learn about single slit. Okay, so we go to the first learning objective. 8.5a, define diffraction, and 8.5b, explain with the aid of diagram the diffraction of a single slit, and 8.5c, use equation for bright and dark fringes. Okay, so what is diffraction? As we know, diffraction in Malay we call as pembelauan. Pembelauan. Okay, so the definition of diffraction, it is defined as the bending of wave as they travel around obstacle or pass through an aperture comparable to the wavelength of the wave. So dia ialah the bending of wave. Maksudnya wave yang lalu an obstacle ataupun aperture. Obstacle ialah halangan, or pass through aperture. Aperture ialah bukaan, dia akan bend. So for example, we have one wave here. Wave kita bergerak at a speed of wave. Ini ialah wavelength. Okay, at the speed of wave. Okay, so dia bergerak at the forward direction, v. Okay, so kita ada lambda. Lambda ialah length of the wave. When it pass through an obstacle, rintangan, dia akan bend. Okay, dia akan membengkok sedikit dekat obstacle tersebut. Tetapi dia still move at the speed of wave. Okay, so for the case B, the second case, bila aperture ataupun bukaan tersebut lagi besar daripada wavelength. So this is the bukaan, this is the A. Okay, tapi A ni dia lagi besar daripada the wavelength. Okay, so bila A lagi besar daripada wavelength, so pattern yang kita akan nampak ialah dia akan bend menghampiri, maksudnya dia macam lurus juga, dia cuma akan bend dekat bukaan tepi sahaja, tetapi dia still akan lurus dekat tengah. Okay, and the third case, bila bukaan ini menghampiri the wavelength. So yang ini, bukaan ini dengan wavelength ni dia lebih kurang sama. So bila dia lebih kurang sama, dia akan menyebabkan wave itu bending sampai membentuk separuh bulatan. Maksudnya dia akan, bila dia masuk lurus, dia lurus, tapi bila bukan ini lebih kurang dia punya wavelength, dia akan bending, menyebabkan dia membentuk circle, half circle. Okay, so itu ialah diffraction or pembelauan. So as dia lalu obstacle ataupun aperture. Okay, so that is the first learning objective, to define the diffraction. Okay, so we want to learn about diffraction by a single slit. What is mean by single slit? Dia ialah satu je bukaan dia, which is dekat sini. Okay, so formation of diffraction by a single slit. Okay, before this in 8.3 we have learned about double slit. We know that double slit, when light pass through a double slit here, dia akan interferes between each other. Okay, bila dia lalu dekat double slit, so akan ada dua source. So bila ada dua source, so syarat untuk interference terjadi ialah dua sources. So two coherent source. So dia ada source yang pertama dan source yang kedua, dan bila dia interferes, dia akan menghasilkan interference pattern yang kita nampak. Dia akan ada central bright dan alternating dark fringes and bright fringes yang seakan-akan sama besar. So ini untuk double slit. Okay, we know interference pattern terjadi sebab ada dua source yang bertindih antara satu sama lain. Tetapi kalau single slit, macam mana dia boleh terjadinya this pattern? So this is the interference pattern. Okay, so syarat untuk interference terjadi, kita kena ada dua source, two coherent sources. But for the single slit, we only have one source here. So the formation of diffraction by a single slit state here, according to Huygens principle, wave front from the light source fall on a narrow slit and diffraction occurs. So bila light pass through a slit ialah aperture, bukaan yang dekat sini, which is A. Okay, when the light pass through the aperture, the diffraction occur, the light akan bend. Okay, every point on the wavefront that falls on the slit act as a sources of a secondary wavelet and superpose each other. So the wavelet superpose each other to form interference pattern on the screen. Tetapi kalau kita perasan, the pattern here is different from the double slit. Kalau double slit dia sama besar semua. Tapi kalau single slit dia akan ada center bright which is sangat besar compared to the dark and bright fringes yang lama-lama dia semakin kecil. Okay, so that's why kalau kita tengok wave dekat sini, center brightnya tinggi sebab center brightnya besar. Okay, so the intensity pun semakin gelap daripada terang, alternate dark and bright fringes dan lama-lama semakin gelap. So this is the pattern for the single slit. Okay, so the equation for dark and bright fringes untuk single slit, and as we know, single slit dia ialah antiphase. So antiphase ialah permulaannya satu positif dan satu negatif. Okay, alright. So the equation for single slit. Okay, the first one untuk the bright fringes. Okay, so kalau we have bright fringes disebabkan dia antiphase, untuk dapatkan bright kita kena plus half dekat sini. So that's why equation dia ialah yn equals to n plus half lambda d over a. Tetapi untuk dark fringes, so dark fringes sebabkan dia antiphase, the path difference untuk a just m lambda. So equation kita akan jadi yn equals to n lambda d over a. So what is the difference between single slit and double slit is the symbol. Okay, so we have yn, we are not using m, we are using n. So n is the number of order. Okay, so n plus half lambda d over a ialah the slit separation. Kalau double slit, kita guna d kecil. Okay, so a is the slit separation, d besar ialah the distance from the screen, and w is the width of the central bright. Okay, so we are using n here, and n is the number of order. Untuk single slit, kita tak perlu tolak satu, kita terus ambil nilai itu sebagai kita punya n. Kalau dikata n sama dengan 1, dia ialah first dark and first order. Kalau dikata n equals to 1 for bright, so first bright and first order maximum. Okay, so we don't have to minus 1 untuk single slit. So single slit, we tak perlu pening kepala untuk plus 1 or minus 1. Okay, so n is the number of order. Okay, and the most important part in single slit ialah when the question asks you to calculate the width of central maximum. So what is the width of central maximum? It is from here to here. So this is W. Okay, so to calculate the width of central maximum, dia ialah 2y1, which is y1 ialah first dark. So that's why W is equals to y1, and y1 untuk dark ialah n lambda d over a. So dia akan jadi 2 lambda d over a. So W is equals to 2y1, which is 1 ni ialah dark. Equation untuk dark, so it is equals to lambda d over a. So itu ialah equation untuk this. Okay, you kira dahulu y1 untuk dark, so you darab dengan 2. Okay, to calculate the maximum number of order observed, so maximum number of order observed, so we are using this equation, a sin theta over n lambda, tetapi theta kita akan jadi 90 degree kalau dia maximum number of order observed. Alright, so this is the equation in single slit. Right, and these two equation is given in you punya list of formula. And it is y. Y is always from the central bright. So where is your central bright? It is here. Okay. Okay, so kita recap sedikit. In chapter 8, we have learned about the condition for interference to happen. So we have learned about interference. The first condition of interference to happen is we must have two waves that are coherent. What is meant by coherent source? So the coherent source, it have the same lambda and same frequency and constant phase difference. Okay. The second condition, it must have the amplitude that are equal. Okay, ini condition untuk interference to happen. Okay, so the condition. Okay, in interference we have two case. The first one ialah in phase and the second one ialah anti phase. So in phase permulaannya positive amplitude and positive amplitude, or negative amplitude and negative amplitude. So dalam in phase ada dua pula keadaan, constructive ataupun bright fringes, which is the path difference ialah m lambda. Kalau destructive or dark fringes, it is m plus half lambda. Tetapi kalau dia antiphase maksudnya permulaannya satu positif and satu negatif. Kalau constructive equation ataupun bright fringe untuk antiphase, dia ialah m plus half lambda. Tetapi kalau destructive ataupun dark fringes, dia ialah m lambda. Okay, this is the general in 8.1 and 8.2. So we have lane interference. In 8.3, it is interference of Young double slit. So disebabkan Young double slit is always in phase, the equation for Young double slit untuk constructive ialah m lambda d over d, and for destructive ialah m plus half lambda d over d. Okay, so ini untuk Young double slit. Okay, so in 8.4, 8.3 we have learned about thin film. So 8.4 thin film. So thin film boleh jadi dalam kedua keadaan, is either in phase ataupun antiphase. Okay, saya dah ajar macam mana nak tahu dia in phase or antiphase. So kalau thin film in phase, constructive 2nt equals to m lambda. Kalau destructive 2nt m plus half lambda. Tetapi kalau dia antiphase, dan dia ialah thin film. Kalau dia constructive, m plus half lambda. Kalau dia destructive, m lambda. Okay, as for today, we have learned about single slit. And single slit, dia hanyalah antiphase. So, for bright fringes, yn equals to n plus half lambda d, ataupun a sin theta equals to n plus half lambda d, lambda. Dan kalau destructive, we have this equation. Okay, so ni ialah yn is equals to n lambda d over a, yn equals to n d over lambda a, and a sin theta equals to lambda. Okay, so a sin theta equals to n lambda. Right, so ini the summary untuk yang kita dah belajar daripada 8.1 sampai 8.5. Okay, so next kita akan buat example 3.